Bismillahirrahmanirrahim. Today we are discussing chapter 10, that is the limit of accuracies from O-level mathematics. Today we are starting from exercise 10.1. Part C, give the approximations to the nearest millimeters. So we have given a number 5.6 and we have to write its nearest millimeters approximation. So this 5.6 is limited with, is bonded with the lower bounds of 5.55 and 5.65. If it is 5.5 greater than 5.5, then it could be considered as a 5.6, and if it is less than 5.65, then it can be considered as 5.6. So this is the lower bound and this is the upper bound. Similarly for this one, we have this is a lower bound and this is the upper bound. If it is 0.76 or 77 or 78, it will be considered 0.8, and if it is 0.88, no, it will not consider as a 0.8, but if it is less than 0.85, then it is considered as 0.8. So this is the way that we considered the upper bound and upper bounds and lower bounds. This is the lower bound and this is the upper bound. It depends on the nearest millimeters. So this is centimeters, so this is millimeters. So if we consider this fraction point, if you are taking values in centimeters, this fractional point is representing the millimeters. So we are approximating it to the nearest millimeters. Give to the hundredths of a second. Hundredth of a second means the this is the unit position, this is the 10th position, and this is 100th position. This approximation means this value, if the next value will accumulate or will take it as a same. So we considered as a 6.15. If this becomes 6.16, 6.1718 up till 6.24, we take it as a 6.2. But if it is 6.25, it will be considered as a 10.63, because this 100th position, this is the 100th position, will be the answer. So this 10.62 can be written as a lower bound with this value and the upper bound with this value. Okay, so this is inclusive, this is exclusive. So 9.81 seconds can be written as this. Similarly for 4.this. A mass given as a 57 kg to the nearest kilogram is between this and this. It is between 56.5 and 57.5. If it is less than 0.5, I mean 57.4, then we consider it as a 57. If it is 56.5, 56.67, we consider it as a 57. Similarly for this one, for meters and for milliliters. For seconds, this is 9.1. So 100th position has to go. This is a 100th position. So we take it as a this one. So similarly for kg. A drain cleaner uses a pole made up of 10 identical flexible pieces. Each piece is 1 meter long, measured to the nearest centimeters. What length of drain can you be sure that he could reach? So the minimum level that has to be reached. So the number of poles is the length of the pole is 10 and measurement is 1 meter. Ten identical flexible pieces. So 1 meter long. So this is 1 meter long. So each pole has 100th nearest centimeters. Nearest centimeters means 1 meter means this is 100 centimeters. So this is 0.05 centimeters. So this is 99.5 centimeters. This 1 meter is equivalent to 100 centimeters. So 100 centimeters means 99.5 centimeters. This is 99.5 centimeters, and this is 100.5 centimeters. So this value is 100 centimeters is between this lower bonds and upper bonds. So in meter it will be written like this. So for 10 meters this is 9.95 meters. So this is the minimum value that the pole should reach. He will reach 9.95 meters. If every pole is at its lower bond, then it will definitely reach 9.95. But it could reach up to this level if every pole is reaching towards is actually in measurement of at the upper bound side, then we will definitely we may reach to this value as well. But this is the lowest possible value that will definitely reach. For drain cleaning we need a longer piece, so this should be the requirement should fulfilled. So this is at least that pole will reach, all poles combined to reach these positions. A rectangle measured by this, so this is similarly this. Let's move to exercise 10.2 and 10.2. We have these two values, the seconds 11.04 seconds and 13.4 seconds, both to the nearest 100th of a second. So 100th of a second means this is the 100th position, this is 100th position, this is 100th position, this is 10th, this is 10 unit, 10th, 100th. So we have to close to the 100th position. So this 04 can be written as this one, and this 13.06. The upper bound is 20. Go to the nearest. So we will add this one and this one. So we will reach this one. So similarly for this one, this is 86 and this is 98. So for this one we have this upper bound and lower bounds. Two stages of relays are run in times of 14.07 seconds and 15.12 seconds, both to the nearest 0.01 second. So two stages of relay race. So consider the upper bounds of the total time that these two stages. Calculate the upper bounds of the difference between the time for these two stages. So for one of the relays timing is 14.07, and this 7 can be written down as 0.065 and this is 0.075, and for this 15.12 seconds it has a lower bound 15.115 to 15.125 as the upper bound. So the upper bound of two stages is this is upper bound of two stages is 29.2 seconds, and the upper bound lower bound no the upper bound difference. So this is the maximum value to the minimum value. So this is 15.125, and this is if one relay is reaching the lower bound and the other is reaching the upper bound, that the difference maximum difference would be this. So 15.125 minus 14.065 would be this. This is important. So Fa is fitting a new kitchen oven. The width of the kitchen oven, the place where the oven may be placed is 595 millimeters. This is 595 millimeters to the nearest millimeters. So will it definitely fit in a gap which is 60 centimeter wide to the nearest centimeter. So we will take it as a 595.4. This is kitchen oven width, lower bonds, and this is the upper bonds to the nearest millimeter. So this is 59.4 centimeter gap width. So we have given a gap width is 60 centimeter wide. So this 60 centimeter wide gap has a upper bond and lower bonds in centimeters. So the upper bonds of the oven width is 59.55 and the lower bond of the gap width is 59.50 centimeters. So if the oven upper bond reaches and gap width is at lower bond, then oven will not fit. Certainly does not exist here. Certainty does not exist here. So we cannot say anything because if the gap width is nearest to the centimeter, it was in centimeters and it is in millimeters. So this if this is within the bond of 59.5 to 60.5, then this lower bonds, upper bonds of the kitchen oven width, and this is the bond of the gap. So this gap, the size of this kitchen oven width is greater than the gap available to place there. So this is 595 and this is 0.5 mm greater. So in that case, if this is the case, then there is a chance that the kitchen this oven may not be placed at that gap. So let's move to calculate to two significant figure the minimum width of a rectangle with these dimensions. So the area is given 210 centimeter square. This is centimeter square to three significant figures, and the length is given as to the nearest millimeter, near millimeter. So this is area, second part. So for the first one, we have the area of a rectangle is equal to length into width. The area of a rectangle is given as 210. So its upper boundary and upper bond and lower bond is 209.5 centimeters to 210.5 centimeters, and the length bound is 17.885 to 17.895, this values. So for the minimum width or the lower bond width, the lower area and the upper length, this is the lower area and this is the upper length. So this will give the answers in centimeter. This is the lower bond, this is the minimum width that will be achieved, because the area is lower on the lower side, the length is higher, so the width will be minimum in this case. So if we divide this with this value, we'll get a lower bond width of the rectangle. So that was the requirement. So minimum width of the rectangle. So the minimum width will be obtained with this. divisions. Okay, so this area has to divide by the maximum length. Similarly for this one, the population of a town is this, nearest to the 1000. The area is given as 129 kilometer square. This is 2 and a subscript to the nearest kilometer square. Calculate the upper and lower bounds of its population density, giving your answer to 3 significant figures. So this is the population. So nearest to the 100. So this 1000, this is covered within this half thousand is here and half is here on the upper side. So this is 128.5. Similarly for this area, this is 128.5 to 129.5 kilometers square. So the upper boundary of the upper bounds of the population density is this one. So this is the minimum maximum population. This is the maximum population and the minimum area. This is the minimum area and the upper bound population and the lower bound area. So in a lesser area, more population. So this is density is high. So the lower boundary of the population is similarly for the lower boundary population, the area is minimum and the population is high. Area is higher and the population is less. So the population is less and the area is higher. This is higher area. So more people, few people are living in a more area. So the population density would be lower, and this is higher population density. This is lower population density. This is again a very important problem. Density of a gold has to be measured by this. So a bar of gold is a cuboid and measured 8.6 centimeter by 4.1 centimeter by 2.4. So this is the three-dimensional length, length, width, and height. So all the measurements are correct to the nearest millimeters. So work out the largest and smallest possible volume of the bar of the gold. In the first part. In the second, the density of the gold is 19.3 grams per centimeter cube, correct to the nearest 0.1 grams per centimeter cube. Work out the greatest and the least possible masses of the gold. This is again a very important problem. So this is the length boundaries for each dimensions with the upper bounds and lower bounds up to a nearest millimeter. So this is 8.6 is written as this. So similarly for this 4.1 and 2.4, and the largest volume is this is the largest volume and this is the lowest possible volume. So this is the upper bounds and lower bounds have been calculated in terms of volume. So the next part, the density. So this is the density of the gold is this, correct to this 0.1. So since 0.1 is divided into 0.05 on both sides, so this one and this one, and the lower bound and upper bound. So greatest mass is upper bound of the density to the lower bound of the volume. So this is the way. Similarly for this one. So this that's all for today, and inshallah we will cover chapter 11 in the next video session.